All right, today we're going to be finding zeros of polynomial functions. And we're going to be using all the stuff that we learned yesterday. So we're actually going to be using a lot of synthetic division today. And this goes with section 3.4 in your book. So the first thing is the rational zero theorem. And this is basically, long story short, telling you all the possibilities of zeros. Now, it gives you a huge list, and all it says is your zeros are somewhere in that list. It does not tell you which ones they are, and that's where synthetic division will come in and help us. So if you want to know all the possible rational roots or all the possible rational zeros for this function, you take the factors of the constant, so -6, which would be plus and minus 1, plus and minus 2, plus and minus 3, and plus or minus 6. And you divide those by all the factors of the leading coefficient. So your leading coefficient is technically a 1, so plus or minus 1. And you do a little dividing. So you'd say plus or minus 1 over 1 is 1. 2 over 1 is 1. Or sorry, 2. 3 over 1 is 3. 6 over 1 is 6. So what this is saying is that out of these 8 options, some of them will be roots to, or zeros to your function. So it kind of gives you a huge list and you get to whittle it down. So how do you whittle it down? Oh, we're not there yet. Just kidding. Let's try one more. So your possible roots for 3 are positive and negative 1, positive and negative 3. So your constant goes on top. Your leading coefficient, so 4 would be plus or minus 1, plus or minus 2, plus or minus 4. Go on the bottom, and then you set them all up. So 1 over 1 is 1. 1 over 2 is 1/2. 1 over 4, 1/4. And then 3 over 1 is 3. 3 over 2 is 3/2. And 3 over 4 is 3/4. So again, that's a lot of possibilities, but it does, get you those possibilities so you can work from there. So now we're actually going to put it into work. So let's set them up for this one. So 20, yikes. We got 1, 2, 4, 5, 10, and 20. Whew, that was a long list. But the good news is it's over 1. Okay, it's over 1. So really, it's that whole numerator, all of those. So 1, 2, 3, 4, 5, 6, 12 possibilities. 12 possibilities. So how do you know which one it is? You just start, okay? You just have to start. I usually just start at the beginning and work my way through. So let's try -1. We're going to try some synthetic division and see if it's a root. So remember your coefficients are 1, 8, 11, and -20. 1, 8, 11, and -20. Going to leave a little space. And the first step, drop it down, multiply, and add. Multiply, and add. Multiply, and add. So see how there's a remainder right here? This tells us that -1 is not a root. All right, so let's try +1. Again, still 1, 8, 11, and -20. I mean, the good news is your setup, that should be the only thing changing. What do we got? Multiply and add. Multiply and add. This is looking promising. Multiply and add. So that right there, that remainder of 0, tells me that 1 is a root. 1 is a 0 to my function. And then we can actually use what we did yesterday, right? We know that here, what was it? So you have to have x minus 1 to get a positive 1. Here's what's left out when you divide out that 1. So what do we got? Drop your degree, x cubed, so this will be x squared. So we have x squared plus 9x plus 20. 9x plus 20. Now this is something we can work with, right? Here we can say what multiplies to 20 and adds to 9, and we can factor that. So we use that root to make it something factorable. So we have x plus 5, x plus 4, and now we have our 3 zeros. We have x equals 1, right? Set them equal to 0. X plus 5 equals 0, subtract 5, x equals negative 5. And x plus 4 equals 0, subtract 4, x equals negative 4. So there's our 3 zeros. Now, unfortunately, this is a list of 1, 2, 3, 4, 5, 6, 12 possibilities, and only 3 of them would have worked. Okay, so it's tough. Sometimes you gotta plug in quite a few of them to get one to work. So just plug them in, try and get that remainder. Take your time on synthetic division though. Let's try another one. So a little bit easier this time because we only have plus or minus 1 and plus or minus 2. And the denominator is plus or minus 1 again. So 1 over 1 is 1, 2 over 1 is 2. So we're using either of those, plus or minus 1, plus or minus 2. So this time we only have 4 options. A little bit better. So let's start with the beginning. Let's try 1. And our coefficients are 1, 1, negative 5, negative 2. 1, 1, negative 5, negative 2. Drop it down, multiply. Add. You're going to get really good with synthetic division. Multiply. Add, multiply, and root. Right, that's a no-no. Move on to the next one. How about negative 1? 1, 1, negative 5, negative 2. Let's try it. Multiply. Add. Ooh, multiply. Add. Not working. Multiply. Add. All right, let's try 2. One of these is going to work one day. What do we got? 1, 1, negative 5, negative 2. Multiply. Multiply. Sorry, my bad. Add. Multiply. Add. Multiply. I don't know why I put a negative 1 there. And see, even the smallest mistake can mess you up here. Add, multiply, add. And that's what we're looking for. So we did have to test 3 of them, but we finally found one. So what that tells me is that x minus 2 is a factor to get a positive 2. And then remember x cubed, drop it down. So x squared plus 3x plus 1. X squared plus 3x plus 1. Yikes. So this one, I don't know anything that multiplies to 1 and adds to 3. So it looks like we're stuck on the quadratic here. So we know one of our answers is 2. And this one doesn't factor, so we're going to go ahead and use the quadratic. So remember, quadratic is opposite of b plus or minus the square root b squared minus 4ac all over 2a. So we have opposite of b plus or minus b squared minus 4 times 1 times 1 all over 2 times a. 2 times 1 is 2. And we're going to simplify this down. So what do we got? 9 minus 4, so we have square root of 5 over 2. So we have negative 3 plus root 5 over 2 and negative 3 minus root 5 over 2. All right, next example. We're going to keep going with the same thing. Keep going with the same thing here. So we got plus or minus 1, plus or minus 13, and plus or minus 1. We like when it's 1. So again, we only have 4 options. We only have 4 options. We're going to get one of those to work. Let's try 1. So our coefficients, 1, negative 6, 22, negative 30, and 13. 1, 6, 22, negative 30, and 13. Drop it down, multiply, add, multiply, add, multiply, add, multiply, and we like it when it happens on the first time. So we know that one of our factors, is x minus 1. So here's the deal with this one. If you look at a graph, and I'll pull up Desmos, let's see if I can actually do it. I do want you looking at graphs of these. Oh, it's going to delete my work. Well, you'll see it. I went ahead and graphed this function. So if you go to desmos.com, it's a graphing calculator, it's free. If you type this function in, notice what happens at that 0, right? This is one of those bounces. So you know that your multiplicity has to be even. So you know that 1 is happening multiple times, probably twice. Okay, probably twice. So if we go back, all right, let me put back what we had here. 1, negative 6, 22, negative 30, and 13. And we had 1, negative 5. I'm just writing the end result here. Okay. So we knew that x minus 1 happened. When we looked in our graph, we found out that it actually happened twice. Okay, it actually happened twice. So we can actually whittle this down a little bit more. So let's do it. 1, negative 5, 17. We're going to use where we left off. We're going to get this even smaller. So we're going to multiply, add, multiply, add, multiply, add. And again, that's why it should have been 0, because we knew that it already worked again. So now instead of a 4th power, we went to a 3rd power, and we went to a squared. So this winds up being x squared minus 4x plus 13. Now here, we're stuck with quadratic formula again. So opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 2. So here we have 4 plus or minus, what do we got? 16 minus that is going to get us negative 36. And then remember, the square root of a negative 1 is I. Square root of 36 is 6. So we got 4 plus or minus 6i over 2. And we're going to go ahead and divide by 2. So we got 2 plus or minus 3i. So you know your solutions, you know your zeros are 1, 2 plus 3i, and 2 minus 3i. And again, we should have 4 solutions, but remember the multiplicity, 1 actually occurs twice. 1 actually occurs twice. So definitely check out those graphs and see if you have those bounces, because then you know that it happens multiple times. All right, I'm going to pause this and I'll pick back up on video 2.